In today's video, we're going to give a quick overview on the life cycle of a star. So everything starts here in a nebula. A nebula is a bunch of just particles of gas, basically protons, floating around into space. And then eventually gravity starts to pull those pieces together. And what we're going to see starting to form in this nebula are what we call protostars. These are early stars. Nebulas are also known as the nursery of the universe. This is where stars are starting to be formed. In this nebula, you're going to have these particles being pulled together by gravity. Once you have enough particles, you're going to begin a nuclear reaction known as fusion. In fusion, smaller atoms are pressed together under extreme pressure into larger atoms. Their nuclei are actually combined. Right? In doing so, we release a massive amount of energy, and a star is born. Okay, here we have two forces at work. One force pulling in on the star is gravity. On the other side, pushing out with an equal amount of force is this nuclear fusion. Okay. This stage of a star's life is known as the main sequence. During this time, the star starts out hot and bright and gradually moves white, yellow, orange, red as it cools down and becomes dimmer. If you were to look at a completed HR diagram, you would see that these main sequence stars are found in this band right here, beginning at the bright and hot stars up here as they're young, and as they age, moving down here towards the dimmer, cooler stars. The next stage in the life cycle of a star is a giant or a supergiant. What happens is this main sequence star, which is where the star has spent most of its life, by the way, it's where the sun currently is in its life cycle. It's a medium-sized main sequence star. But the stars have started to run out of hydrogen, and they've started to compress in on themselves because of that. When they do, the stars resort to turning helium into carbon, which causes the star to swell even further. So what's happened now is we have more fusion than we do gravity, and the star has begun to expand. Now when this happens to the sun, we expect that the sun is actually going to expand out to about where Mars is right now, which will be bad news for the Earth. So set your timer. In about 4 billion years, we need to be worrying about the sun turning into a giant or supergiant. Until then, I think we're going to be okay. These giants and supergiants are bright, but not as hot as the other stars. So let's look and see where we would find those on our HR diagram. So we would expect that the giants and supergiants would be up here. They're not very hot, but quite bright. What happens next really depends on the size of the star. When we're talking about smaller stars, and by that I include the sun, anything about 9 times as large as the sun and smaller, it's going to simply fizzle out and become a white dwarf. So a white dwarf is a relatively dim star, not nearly as hot as it used to be, and it's just going to slowly fizzle its way out until it no longer has enough fuel to undergo fusion and then just kind of die. If we go back to the HR diagram, we can find that white dwarf right down here. Again, it's not very bright, and it's losing its heat. So that white dwarf will be right here. What happens to larger stars is a bit more exciting. So stars that are bigger than 9 times as large as the sun are going to collapse in on themselves. They no longer have the fusion that's required to keep them as a supergiant, and gravity collapses them, and they explode and become a supernova. Supernovas are just massive explosions. Now again, the smaller of these larger stars is going to become a neutron star. Neutron stars are incredibly dense. 1 teaspoon of a neutron star is 10 million tons. All right, if the star is not just big, but really big and a supermassive star, then it's going to go the most destructive pathway possible, which is to become a black hole. Black holes are stars which are so large that the gravity is so strong that light itself cannot even escape it. We could talk forever about black holes. People have devoted their entire careers, like Stephen Hawking, trying to figure out what happens inside a black hole. But we'll just let you know right now that that's the pathway for the largest and most massive stars is to undergo a supernova and then become a black hole.